guys, so you may have noticed in some of my social media that I've built a log splitter press, a fairly low powered one with a little tiny log splitter, and it's something that seems to cause a bit of controversy in the community. There seems to be the people that swear by it and think that it's a great idea, and then there are people who think it's useless, it's pointless, never get enough power out of one of those to do anything practical. And so this video is kind of supposed to be the last word, I suppose, because I've been using one now for a few months, and they have their pros and they have their cons, and most people don't build them right. So let's have a talk about the design of them, what you can do with them, and really what you can't do with them. So this is mine. It's Mr. Squishy. And you can see all that's really been done is on the ram that slides, normally pushing a log, I have mounted a die plate, and then where the blade is that would normally split the log, I've actually attached a brace here with another plate that can put dies in there as well. And I have interchangeable dies that can be swapped out very, very easily, just like so. And you can get different types of dies, and because I've used standardized sizes, I can keep making new dies if I need them. And I can also make combinations of dies to get desired effects. Now, there's a couple of small differences you may notice between my log splitter press and other ones that you may have seen on YouTube. And the main one that you may notice is there's actually a collar around here. We'll get into why I have that here. And the other one is that I have not centralized it. There's not a extension here and an extension here with the meeting in the middle. We'll also talk about why that happens. And the reason you don't want to do that is physics! Most people find these to be underpowered. This is 7 tons with a maximum output of 8 tons. Most people find these to be too underpowered for forging work because they build them wrong, and they are at most getting 3 or 4 tons of power out of them, which is not really enough to do much in forging. So let's talk about the physics of why these need to be designed a very specific way in order to work. So there is a strange phenomenon that people seem to think that when force is coming in what looks like one direction, it's only going in that direction. But oftentimes, a slight deviation of that force is enough to actually cause a certain percentage of the force to be redirected in a perpendicular direction, which sounds really complex. But a good example of this is a footbridge in London that was built a while back, and was cost millions to build. It was a huge deal socially, going across the Thames, and it was the big day came and they opened the gates and all these people flooded onto it, and all of a sudden this bridge started going like this, sort of snaking, and they were worried that the whole thing was going to topple and fall down. And a lot of very clever people had designed this bridge, and they couldn't understand why it was suddenly swaying sideways. No up and down movement whatsoever, but it was swaying sideways. And what they hadn't accounted for was the fact that as people walk, they're not just putting force down. If they step with their left leg, they put a little bit of force to the left, and when they step with their right leg, it puts a little bit of force to the right. And the combination of hundreds of people going across the bridge at the same time doing this created huge amounts of left and right force. And the same thing's actually happening in a modified log splitter press. People just don't see it until you put the collar on, and then it becomes really, really apparent. So let me get some diagrams here to show you what I mean. So the way these small log splitter presses work is fairly simple. You've got a main carriage, that's the red piece in here. Inside that carriage is actually the hydraulic tank, and the hydraulic fluid is stored in that tank, held around the piston that's actually pushing out. The piston runs the entire length of it, and actually comes out this side here when you operate the press. Either side of that piston are ramrods. There's one on this side, one on this side, and those ramrods go all the way back, and they're attached to this carriage here. And there's an underslung frame that goes up, is connected to that, and that makes the entire thing slide along that red outer chassis. as that moves forward, it eventually makes contact with whatever's on the other side, and it exerts the pressure that way. So the pressure of the ram is not actually pushing against the workpiece. It's the pressure of the ram pushing on the ram rods and into this. So it's a pull force, not a push force. And because of that, the ram is down here in line with where my hand is, and the actual work is up here. So this is actually creating a triangle of force. So the push point is here, but it's actually pulling the work from this angle, not straight. Everyone sort of just assumes, well, the ram's moving this way, that means the force is moving this way, but it's not. There is a point where the workpiece is here, and draw a line all the way down to where the ram is, and that's actually an angular force, not a linear force. And that angular force means that when you touch this die to this die, that needs to go somewhere. So with this collar in place, without this collar in place, I should say, this would actually get pushed up and away. And you can see a little bit of that when I do that. So any movement of this brace upwards is stealing force, squish force, and pushing it into a pivot point here. Because we've got a triangle here, in order to create the square of the completed sort of force circuit, there's another one here down to this point and across there. And so when you pull across here, it pushes across here. And that's how, because every force, every action needs an equal and opposite reaction. That's just physics. And so because of that, you need to prevent this from lifting up as much as possible to capture that force. I have gotten about a 3 millimeter or 1/8 of an inch of slop in my collar, which allows it to move up as much as it does. But if you have a look at some of the other videos on YouTube, you'll notice that it moves up about 1 inch or more on some cases. And so not only are you losing a lot of your actual crush force, you are putting huge amounts of strain on your welds. Now, talking about those welds, not only has it been thoroughly welded with dissimilar metal rods to make it very, very strong, you'll notice there's a fin across here which is creating another triangle, which is exerting downward force here and adding more stability to the piece. Everything about this blue part here, lovely and color-coded, is keeping this piece in place, no matter what happens to it, as much as possible, because the more this stays still, the less force you're going to lose. Now, if I were to have another piece like this attached to this ram, and this entire throat assembly here were more central, not only would this be lifting up, but this would be lifting up as well, and I would be losing twice as much force. So that's why I have it set up the way that I do. It would happen exactly the same way, except it would be happening twice over. This is always going to have slop in it. No matter what you do, you can't stop that. You can shim it to a certain extent, but if you shim it too much, it will create wear on the cylinder, and you do not want wear on your hydraulic cylinder, because that's how accidents happen. So it's better to just leave it sloppy and adjust how you use it. So because when your rams are coming together, it moves up like this, it means one side of your work is going to get crushed just a little bit more than the other side. And that's okay. But if you don't check it, as you're drawing out a bar, for instance, that bar is going to bend exactly the same way as when you're forging in bevels on a knife, it bananas in shape. So every time you do a press, you just need to flip it 180 degrees and do the next one on the other side. And this will actually keep it from warping out of place. So instead of forging a single bevel, you're forging a double bevel, essentially. And this will actually make surprisingly accurate billets. Now, I've found that in order to get the most out of something like this, you need to actually have a combination of 3, possibly 4 different sets of dies. Now, the first one you want to do is to use rounding dies, which look like this. So it's literally just a round. And so when you're crushing it, the surface area is minimized and you get the maximum amount of force possible. It does make an ugly billet though, leaving it all lumpy along the sides. And these can actually crush a billet so well that I'll turn a 2-inch billet into a 5mm billet in just a few passes. So these are really great to start with, but they do leave your billet ugly. So then you need to square them up. And that's why you have square billets. Narrow faces here are the key. This is inch square stock. So inch square I find is very good, and because you're taking small bites, you can actually have a bit more control over the amount of squaring. And sometimes if you go too far with these, they can leave ugly divots in your work, so you have to be careful. I wouldn't go much wider than inch wide on something like a 7-ton press though. Once you've neatened it up somewhat with this, you can then switch to flattening dies, which look a little something like this. And that is about 2.5 inches wide, which you could even go a little bit wider, and they work really, really well for neatening up the sides, straightening everything out, and generally giving you quite a nice grindable billet straight off the press without much hand hammering. It does help, however, when you're using that, to have an anvil nearby, especially a nice long-faced anvil like my B&W anvil from Beamish Anvils. It's great to be able to sort of just tap that out, sight down it, get it all straight, and it'll make your grinding process much easier. The final type of die which I plan on making, which I would consider very handy in a basic set of dies, would be a fullering die. So it would be just like my round dies, except it would be going this way. I may even make it quite a shallow fuller, so use square bar like this, but then ground in a nice wide profile, and it just allows me to widen bars up a little bit. It gives you a lot more control to have that option, so I would recommend doing those as well as your core 4 sets. From there you can get really creative with what sort of dies you put in there, and it's why having a modular die system like this makes it really, really sort of optimizable to your workflow. Now, everyone likes to say you should get the biggest press possible and all that, but presses are expensive, and especially made forge presses, because they know that people are getting interested in things like forged to fire and they want to use them. But I'll tell you what, if you're making a large amount of Damascus and you're used to doing it by hand, getting a little forge press sorted out of a log splitter like this is cheap, it's very doable, and it's very easy. It makes the whole process of making Damascus a lot less physically intensive, and it takes less time. You can move more steel in fewer heats, which means you lose less steel. And you can even, when you get used to it, develop the control to put on nice little tang shoulders and things like that. It's a very optimal way of doing things because it's easier on your body and it just gets things done quicker. So there's a way of building these that I've seen, which I'll link up here, that I really like. It's if you're confident with welding, because you'd want to, with 7 tons of force, you'd want to make sure your welds are good. But if you're confident with welding, then check this video out, because his way completely bypasses all of the problems and just directly links the ram force in line to the workpiece, and he is getting absolute maximum force out of it. Ideally that's the way you want to go, but however you do it, you really need to somehow link the pedal and the power switch together, because the way that they are designed, they will not work with one or the other. You press the power button and hold it and push down the lever, so it's two-handed operation. And I suppose they do this so that you don't go and operate it and then stick your hand in it or something. It's a safety measure, I guess. I don't know, it seems pretty weird. If anybody's going to stick their hand inside of a log splitter, then they kind of deserve to lose the hand, if you ask me. But somehow you're going to have to wire up a pedal that you can operate by your feet, so you've got 2 hands to work with. It doesn't necessarily have to be a foot pedal. You can have just one lever doing the whole thing and have one hand holding the work and one hand working the lever. I like the pedal. The pedal leaves both hands free and not just one. Otherwise, if you have an assistant helping you, that's always good. But since you're doing a press, 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 it's better to have full control over it, and I find a pedal's the best way to do it. So I actually have my power button mounted on the underside of my pedal with a chain leading up to the lever, so when I press the pedal, not only does it push the button, it pulls the chain which pulls the lever, and the whole thing works. Now, they do have a little bit of a dodgy return system on them. Sometimes you'll be going meh, 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 and it works fine, but then all of a sudden the pedal just won't work, and it'll just, you hear the motor going, but it won't actually engage and start working, and you have to let it slide back a bit before you can start again. It's a bit of a pain. It's just one of those little, you just got to deal with it, unfortunately. But if you've got a forge right next to it, it doesn't take long to get back up to temperature if that happens. And you can just keep going. Either way, they're still cheap, they're still easy to build, and they still do a damn good job. So it's not really that big of a deal. I have mine up on a stand that I've made for it, and that allows me to move it around a bit easier because I can take the press off and move the stand separately. And that allows me a little bit more freedom with where I put it. I had originally planned to have it in my forge. You can see I'm outdoors, I'm not in my forge. I'm outside my finishing shed, because my finishing shed has power and my forge does not. My original intent was to actually put it on a petrol generator, but petrol generators actually work by having their throttle adjusted based on the power consumption on the generator, and having it go up and down, up and down, up and down by me doing meh, 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 meh sort of movements, it just stalls out the motor. So not good. So I have it up here where I can just plug it in to an electric outlet. I could do a petrol powered log splitter, but I think it would run into the same problem. It would just be all internal instead of having a generator attached to it. So yeah, that's all of the sort of nuance that I can think about. If you build it right and you're only doing sort of small projects like small billets of Damascus, mine are about 2 inches by 1 inch by 4 inch. That's usually about the size of billet that I do. Sometimes I'll do 2 inch by 3 inch and 5 inches long if I really need a lot for a project. Most of my projects don't need that much. It handles it just fine, it really does, and the modularity of the dies make it a very, very good tool. It does have its idiosyncrasies, it does have its limits. Now, obviously 7 tons of force, even 9 tons of force is not enough to do huge amounts of squishing. For that, if you're going to do that sort of route and you're working on hammers and things, I'd get something like a 25-ton log press, a bit like my boy Big Fudge. Check out his video on his build, because he's got a monster. So that's Preston. So yeah, that's everything I can think of on that. Hopefully you found this video illuminating, and if you were thinking of taking the dive and building one of these, go ahead and do it. Just build it right. Make sure you get those little nuances worked out so that you get the most out of your press, because you don't want to have sort of builder's remorse and not like what you come up with. So, as usual, guys, links are in the description below for all of my socials, Facebook, Instagram. I'm on Patreon. This video is coming at you thanks to my awesome Patreon supporters. I'm back to streaming on Twitch now, so definitely check that out. And yeah, I'll see you guys on the next video, which shouldn't be too far away, to be honest. It's already half done, so sorry it's been a little while. Still working on everything, just really flat out busy, so I will be catching you again very, very soon. See you later.
There was a time when a day